You determine how many peaks you would expect in the HNMR of this molecule here. Pause to try. Let's break this down. So first, let's draw out all of the invisible hydrogens of this molecule. I have drawn out all of the invisible implied hydrogens of this molecule in green. And be careful here of the tertiary positions, which are going to be this position, and this position right here. A lot of students forget about this sneaky hydrogen here that is hiding from you, right? So now these three hydrogens right here look different the way that it's drawn because they are in different locations, but know that this molecule is one snapshot in time. And we know that this single bond here can do free rotation, which will have these three hydrogens orbit around each other and they would experience the same chemical environment. So that would be our first unique peak of hydrogens right there. This will be through the same reasoning. There are no protons here, right? This is a unique proton. This is a unique proton. This is a unique proton. Now, be careful here. We know that this is a sigma bond that can do free rotation. These two hydrogens here look different than these two hydrogens right there, but because of symmetry, imagine that this ethyl group and this ethyl group rotates around into each other's chemical environment. That would make these two hydrogens experience the same chemical environment as these two hydrogens. So these four hydrogens here would be in one peak. So that would be another one. So this would be our fifth peak. Our sixth peak. And the same reasoning as for these three hydrogens here. These three hydrogens can orbit to those two hydrogens, making that our seventh peak, which includes 6 protons. This hydrogen here would be our eighth peak. Now, if you try doing the same technique as for these three hydrogens here and these three hydrogens and say that they're the same peak, you cannot do that because this is a double bond right there. And because there's a pi bond, we can't do free rotation, making them stuck at these positions, making them different peaks. So this would be peak 9 and this would be peak 10, right? So let's make sure we have the correct peaks here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And do not forget about this hydrogen on the alcohol as well. So that would be our 11th peak right there. As a challenge problem, comment below how many sub peaks would peak 3 have on the HNMR. If you want a free organic chemistry tutoring session from me, then DM or comment organic.